In this problem we have a package being released by a plane at a certain height up. So drawing the diagram, we put our package here at the point of release. It goes off at an angle, we're told, of 45 degrees. We're also told that it's released at a height, y, of 625 meters. The last piece of information we're given is the velocity that the plane lets go of this package at. Now, since the velocity is letting go of this package while the plane is going up at 45 degrees and at 102 meters per second, that's the initial velocity of the package. Initial velocity of the package, 102 meters per second. Now what we want to find is the distance that this package travels in the x direction. We're given some of the information in the y direction. What we want is basically this distance, x. So in order to find this out, we have some initial information. And where we're going to go with this is to figure out exactly how long it takes this package to go up and then down. And then we use the x components of the velocity to figure out how far it's going to go in that amount of time. So we put our axes on as y and x in their regular directions. And to start, I'm going to figure out my x and y components of velocity. So v naught y is going to be sine, so 102 meters per second sine 45.0 degrees equals 72.125 meters per second. Now when we do the x component should work out to be the same, just because sine and cos of 45 have to be the exact same thing. So v naught x equals 102 meters per second times cos 45.0 degrees. Run the numbers through and you'll see that it does equal 72.125 meters per second. So we have our initial velocities in the x and y directions. So now we're going to look at solving for the time it takes for this package to get to the ground. So we can say y equals v naught in the y direction times t plus 1/2 acceleration in the y direction times time squared. Now, we're not going to be able to just solve for time because we have a time and time squared. So let's put in what we know. We know y is going to be negative 625 meters. It's negative because this is our initial position, this is our final position. We go down 625 meters. Initial velocity y is 72.125. It's 1/2. Acceleration in the y direction is just negative g minus 9.8 meters per second squared times squared. Now, we can't figure out for time yet because we just have t and t squared, so we can't cancel anything out, and none of these are zero. So what we have to do is use a quadratic equation. So first I'm going to move this 625 over, so we have 0 equals 625 meters plus 72.125 meters per second t minus, I'm just going to take this 9.8 and divide by the 2 to give me minus 4.9 meters per second squared t squared. So, quadratic formula has an a, a b, and a c. The a is always the squared term, whatever's multiplied by your variable squared. So that's a is minus 4.9. 4.9 meters per second squared. B is always multiplied just by a variable. So 72.125 meters per second. C is your constant, 625 meters. Okay, so now we write down our quadratic equation. T equals negative b plus minus square root b squared minus 4ac, all divided by 2 times a. So I'm going to plug a, b, and c into this equation. T equals negative b of 72.125 meters per second, plus or minus, which is going to give us two solutions, square root b squared, 72.125 meters per second, all squared, minus 4. A is minus 4.9 meters per second squared, minus 4.9 meters per second squared, times C, 625 meters. All divided by 2 times A minus 4.9 meters per second squared. Okay, so plus or minus, this will give us two answers. If I first of all just look at my units, and we'll see what we'll work out to. We have meters squared, meters per second, all squared, so that gives us meters squared per second squared. Meters times meters, so we also have meters squared per second squared here, and that'll be all one. Square rooted ends up giving us meters per second, so plus or minus meters per second. So our whole top units is meters per second. And we divide by meters per second squared. Second squareds go to the top, meters go to the bottom. We end up canceling out our meters, and we're left with 1 second on the top. So the units work out in this case. And what we have to do is now plug in all our numbers, square this, subtract off this product, take the square root of it, add it to this number, divide it by this, and then again take this number, subtract it from this number, and divide it by this. Now, since I've done this, and you get a positive number and a negative number. If you get a negative time, you don't use that, because you're not going to get a negative time to go from here to here. It's always going to be a positive time. So we have t equals, after plugging all this in, we get an answer of 20.8 seconds. That's the total time it takes for this package to go up and drop back down. So now that we've figured this out, it's the same with basically any projectile problem. If you're given an initial velocity and you know what direction it's going and the height it's at, you can figure out exactly how far it travels. Or conversely, if you're given how far it travels, you can figure out how high it is. In this case, all we need to do now is use our distance formula in the x direction. Now x equals v naught t, v naught x, plus 1/2 acceleration in the x direction, t squared. X equals v naught x is 72.125 meters per second times our time of 20.8 seconds plus a whole big zero here, because this acceleration is 0, so this whole term just turns to 0. So our final x distance, after we plug that in, gives us 1,500 meters. So put in scientific notation with 3 significant digits, 1.50 times 10 to the 3 meters. That's our final answer.